There are many videos about the benefits of Bitcoins. The value of a Bitcoin has increased dramatically in recent months. But actually, the technology behind Bitcoin is unknown to most of their owners. I believe that in about 90% of all publications the functionality of Bitcoin is described like this. Alice wants to transfer 5 Bitcoins to Bob. Her Bitcoins are stored in a wallet that has an address like an account number. When making a transfer with Bitcoins, no banks are involved or taxed. The transfer can neither be tracked nor extra fees added. Furthermore, a transfer cannot be reversed, and it happens immediately. Most of those benefits are either wrong or were correct in the past. This description of Bitcoins for ordinary people is the same as if you were saying that in a 200 horsepower car, 200 small horses running under the hood. With this video I'll try to explain the real functionality of Bitcoins and start by destroying the first wrong fact about Bitcoins. There are no Bitcoins. There is no file or string representing a Bitcoin. Accordingly, there are no Bitcoins on any hard disk, any mobile phone or USB stick. In fact, there is only a kind of an electronic bookkeeping ledger, stored as a big database. So if Alice transfers 5 BTC to Bob, there is no Bitcoin file that will be moved from Alice's wallet to Bob's wallet. In fact, a new entry is created in the general ledger, which documents the transmission of 5 Bitcoins from Alice to Bob. But, if there are no Bitcoins, what is stored in the wallet? There is no kind of bank deposits as we might think. There is not even any kind of a bank account. The Bitcoins Alice is allowed to spend are previous bookings in which Bitcoins were transferred to Alice before. So-called UTX, so that means unspent transaction output. In our example, Alice got 5 Bitcoins from Dan before and she uses the ID of this entry as her credit. But if there are neither Bitcoins or accounts nor credits, how is Bob credited with this booking? Here is a concept from cryptography that is called public key cryptography, or asymmetrical cryptography. The public key encryption method was invented primarily for encrypting data. For this purpose, a pair of keys is generated. One key is used exclusively for encrypting data, called public key, which may be disseminated widely. Here shown as a padlock. In this example, the text "Hello World" is encrypted to something unreadable, using the public key. And another key that is used only for decrypting data, called secret key, will be created to decrypt the encrypted data. The secret key should be kept secret and only known by the owner. However, nothing is encrypted in Bitcoin transactions, but another technique from the public key encryption is used, called signing. When signing, a small string, the digital signature, is created with the secret key and the data to be signed. This signature and the, still unencrypted, data can now be checked with the help of the public key, and you get the statement whether this data was signed with the private key corresponding to the public key. So nothing is encrypted, but you get the assurance that the one that created this signature has the corresponding private key. The private key is the access to unspent transaction output and thus the part that makes up the Bitcoin balance. When it comes to the theft of Bitcoins or loss, no Bitcoins are stolen or lost, but just these private keys. Therefore, the private key should be kept safe. The Bitcoin addresses are not account numbers or similar. Those addresses not even stored or deposited in any higher level instance. In fact, Bitcoin addresses more like independently created public keys with which transactions can be locked. If you take it exactly, the Bitcoin address is not 100% a public key, but it's a generated value that has the public key as its initial value. So we still use the padlock as this symbol. In fact, the transaction is an entry in the ledger, blocked with a public key. so this transaction can only be used by the one who could prove to have the corresponding private key. In this example, hopefully Bob. Ultimately, no personal data is contained in a transaction, which suggests anonymity in the Bitcoin network. For the sake of completeness, Alice also has a private key and a matching Bitcoin address. Because Dan blocked his entry for Alice with her Bitcoin address, I have skipped a problem in my example by letting Alice transfer exactly the amount to Bob, which she previously received from Dan. But how is an amount transferred that does not exactly match the value of a previous transaction? For this purpose you define the amount to be transferred to the receiver address and create a second line, with the difference amount, back to your own address. It is similar when you want to transfer more Bitcoins than the largest DOT transaction contains. For this purpose, several DOT transactions can be combined until the required sum is reached. In our example, Bob wants to spend 10 Bitcoins on Alice. He uses 2 entries, with a sum of 11 Bitcoins. Luckily, you can also set the output quantity exactly and send the change back. Bitcoin consists not only of the general ledger, but of a multitude of autonomous servers that keep the Bitcoin universe going with different tasks. The participating servers are called nodes. The ledger, the database in which all transactions ever made are persisted, is not centrally stored nor maintained and not even managed by any institution. In fact, there are very many copies of the ledger on different servers called full nodes. Therefore, it is a distributed ledger. The nodes are in constant contact to have as identical a state of the ledger as possible. How does an entry get into the ledger? An entry, called a transaction, consists of an input, with one or more UTXO, and an output, with one or more addresses. This transaction must be sent to a full node. The full node checks the received transaction according to several criteria and stores it, after successful examination, in its mempool. Thereafter, the transaction will be forwarded to all known nodes. At this time, those transactions are not yet firmed entries in the global ledger. They are unconfirmed transactions right now. Further transactions to other nodes will be submitted, reviewed and forwarded. Now the process called mining takes place, which leads to the irreversible storage of transactions in the general ledger. For this purpose, server called miners move unconfirmed transactions from the mempool to a data construct called a block. The process of the mining is performed independently in each miner. A miner can independently decide on the transactions he wants to include in his block. First of all, the miner generates a digital fingerprint, called a hash, from every transaction, with a cryptographic hash function. The used SHA-256 function is a cryptographic hash function that has the following characteristics. It is deterministic, so the same message always results in the same hash. It is quick to compute the hash value for any given message. And the most important feature, it is infeasible to generate a message from its hash value except by trying all possible messages. Once the hash has been generated for each contained transaction, a new hash value is calculated from 2 previously calculated hash values. The pairwise creation of 2 hash values is called the Merkle tree and results in a single hash value called the Merkle root. The Merkle root is therefore the hash for the entirety of all transactions in the block. Now comes the hard part of the mining. After the Merkle root has been calculated, it is entered in the block header. The block header does not contain the Merkle root only, but also other data relevant to the security and immutability of a block. Each block has its own hash. How this is calculated, I will explain later. However, it is important that the hash of the previous block must be present for the calculation of the current block hash. The new hash from the block is calculated from the values in the block header. But this new hash value must not exceed a certain value called Bitcoin difficulty. For this task, a counter called nonce is placed in the header, which must be changed until the resulting hash meets the requirements. Since there is no way to draw conclusions from the hash to the original value, guessing is the only way to find a conclusion hash value. Guessing the nonce is the main task by mining. This process deliberately slows down the mining process to make it difficult to modify the block in the future. The block is still not part of the general ledger at this time. The Bitcoin difficulty will be adjusted every 2016 blocks to predict that a block will be found every 10 minutes. Actually, the hardware used from most of the miners to compute the block is so specialized that with normal hardware you will not find a valid block in 10 minutes. The ledger is actually a gigabyte-size database, made up of several such blocks. After a block is found, this block is chained to its previous block by incorporating the previous block hash. And here it is, a continuously growing list of blocks, which are linked using cryptography, the blockchain. As soon as a miner has created a valid block, he sends it to the Bitcoin network. Each full node, in turn, checks the correctness of the block by recalculating the entire hash process itself. If the node encounters the same block hash, the block is correct. Then he adds the new block to his own blockchain. If this node deals with a miner who has himself searched for a valid block, his work has become worthless because his calculation no longer refers to the current last block. By having multiple miners working simultaneously on the next block and the synchronization between the nodes taking a certain amount of time, other miners can also find blocks before all the block chains have the same state. As a chain is known to have only one subsequent block, but several blocks are correct successors of the last block, this results in the ramification of the blockchain. In such a case, the nodes keep these different branches of the blocks until one block gets longer in the further processing than all the others. Incidentally, length in this context refers not only to the number of blocks, but also to their content or how much work was put into creating the block. For example, the block of 10 transactions is likely to be longer than 2 blocks of 4 transactions each. All blocks in the shorter branches are finally discarded. This could be a problem for all the included transactions in those removed blocks, because if it is not in the blockchain, it never happened. To ensure that a transaction is contained in the dominant block branch, you could count the number of follow-up blocks created after the block containing your own transaction. These blocks are counted as confirmation. After 6 confirmations, it is assumed that the corresponding block will remain permanently in the blockchain. The motivation for mining blocks to run the Bitcoin network is a reward. Each miner can add as a transaction to his block that attributes Bitcoins to his address and does not require an incoming transaction. The transactions, called Coinbase, generate Bitcoins from nowhere. How many Bitcoins a miner can credit is defined in the Bitcoin protocol and is currently 12.5 Bitcoins. The Bitcoin base value halves every 210,000 blocks. In addition to the Coinbase value, there are transaction fees, which you can add to each transaction as a tip for a miner. The transaction fee is not explicitly stated, but is a desired difference between input and output. In our example, the output contains 0.5 Bitcoin less the sum in the input. These differences in the transactions, a miner can add to his Coinbase. A miner therefore attempts to include transactions in his block where the ratio between transaction size and transaction fee is best for him. In conclusion, it can be said that Bitcoin technology is a technical masterpiece. However, his success has currently made him useless as a means of payment. Until a transaction is permanently received in the blockchain, hours will pass if not days. And then only if a generous transaction fee is given. The useless consumption of computing power when creating new blocks hurts a bit. Maybe the next generation of cryptocurrency uses its energy to cure cancer or something like that. That would be perfect.